Hello everyone, how's everyone doing today? Alright, today we're gonna actually redo the first stream of going through the Surreal University, because the first time I forgot to click go live, so I wasted some time talking to myself. But I'm gonna redo that. We're gonna go relatively quickly through the first part, alright? So, why are we going with SurrealDB University? I want like a quick, nice refresher on SurrealDB. It was a while since I streamed. I never had a good chance to look at it. So I figured, let's just have a good refresher. So SurrealDB University, I'm gonna play a little video that they included, and we'll see if we learned something from it, all right?
The goal of this course is to help you build your idea as soon as possible.
Okay. Gonna have some live coding. We're definitely not using light mode. All right. Guess that's a nice little intro. All right. So looks like we have 4 courses to choose from right now. A tour of SurrealDB, explore a quick overview of SurrealDB. That's what we're going to do today. Then we have SurrealDB fundamentals, and Surreal Renaissance, which is, I think it's quite fun. I just took a peek. It's more like a storytelling thing. And SurrealDB documentation, that's just a documentation. Oh, so we have 3 courses. All right. And yeah, this is just, I don't know, just your generic stuff. But yeah, we've got quite a crew teaching those courses. So that's awesome. All right, so let's go with a tour of SurrealDB. Welcome to the tour of SurrealDB. This tour is designed to give you a basic knowledge of SurrealDB in as little as 30 minutes. We're not gonna do that in 30 minutes, not with me talking and explaining, or a few minutes a day over a few days. We will talk through a small project to create a database that holds a library inside a charming town called Riverdale. You can see part of Riverdale's downtown in the image above, while the library is more out towards the suburbs. So yeah, this is very fun. We have Statement Street, Record Link Way, we have Push Domain Street, Index Avenue, Event Junction, and Access Cord. All the fun stuff. It'll be actually fun to, like, if there was like a neighborhood with all those names. Inside the library, we will add information, inside the library, we will add information including its books and their authors, the library's employees, and customers. We'll also map out some of the streets and places downtown and use an algorithm or two to show the paths you can take from one place to another. Awesome. This tour is the shortest of our 3 university courses and moves from concept to concept with a minimum of explanation for each page. Yeah, we're going to go through it relatively fast. If you're still hungry for more and you are done with the tour, check out the longer SurrealDB Fundamentals course and the immersive book and SurrealDB Renaissance. So let's get started. All right. Connecting to a database. The examples in this course are inside many windows of their own that look like this. And we can click run, right? We can click, and there we go. We have our query and the results, right? So that's awesome. And also this. Bam. Don't just forget the semicolons between statements or you will get an error. add some semicolons to make the statements work. So if we're gonna do run, we have the previous query. But yeah, you don't need to think about installing SurrealDB or starting a connection of your own to run any of them, and we won't. But you can also run the examples in a more manual way if you prefer. Here's how to do it. We can do it in Surrealist Sandbox, using the Surreal Cloud, or I know, install SurrealDB on your machine, or maybe use a Docker container or something. There are just a million ways. Just have SurrealDB and you can try it. But we don't have to because it all runs in the browser, which is awesome. Okay, so to the content now. Let's see if I can make it disappear. Yes, awesome. Make it a bit larger for the stream. For those who are on a smaller screen. It's always nice when it's easier to read, right? Okay, so creating records. To create a library, we are going to need a record for it. A create statement followed by a table name is all that we need to create a record. So we do create library. Bam. And for some reason, we always get the previous query. Something's not right. Let's refresh that. This was working previously. Are all of them like that? Oh no, something's broken. Huh. It was running nicely earlier. Okay, we're gonna run it ourselves, all right? We are going to run it ourselves. So create place, set place type library. Create library, right? So let me open up Surrealist. And, we have it here. So sandbox, can we clear sandbox? Reset, there we go. So create a library, right? When we run this, we get, hey, this is our ID, library. All right. But since our town is going to have all sorts of places, let's choose a more general table name, like place, right? We can use the set keyword to give this record a field called place type so that we know a bit more about it. Okay, so create place, and we can set that the place type is library. Wonderful. So we're going to do that. We run it, and we can see that our query resulted an array of a single object with an ID, which is starting with our place, and we have the ID and place type library. Wonderful. There we go. Here's the response. Since we don't give this place record an ID, SurrealDB will create a random one. So record IDs are composed of the table name, a semicolon, a colon, and after a table name, and something else. If you don't choose an exact record ID, a random GUID, a global unique identifier, will be added after the colon, which gives an output like place, colon, and some random letters here. Notice that this is not like an UUID, there are no dashes, it's not extremely long. This is a little bit more condensed, therefore I find it much nicer. But you can choose your own record ID instead, like place 1 or place my library. Just make sure that it isn't already used because you can't create a record that has the same ID as another one. So yeah, let's try that. Let's try to create 2 of them called my library. First one worked. The second one is like, oh, sorry, the record already exists. So I'm gonna run it again. Both don't work because my library already exists, right? We can even go to Explorer, place, and there's my library. There we go. But let's go back to query and continue. There we go. So using the Omni keyword. Interesting start. SurrealDB returns an array of results by default. But in queries that return a single record, you can add only to return just the record itself instead of an array of records. So we have create place and create only place. And the difference is that the create place returns an array of those objects that were created, while create only place just returns the object. And that's it. This is useful when working with the output of a query. Instead of needing to use the access the 0th element, so the first element, to pull out the first item at index 0, the output of the query itself is now just a single record. It is also helpful when using one of the SDKs and you want a response that can be deserialized easily into a single object and not fiddle with like, oh, get check if array, blah, blah, blah. So yeah, this only keyword is quite nice. Okay, non-ASCII record IDs. If you need a record ID that goes beyond basic non-accented characters, like ASCII, you can put it inside backticks. In this case, use a non-ASCII part of the record ID. In this case, the non-ASCII part of the record ID will be enclosed in those funny brackets. You can use those brackets instead of backticks. So let's say French language, right? Create only place, and inside the backticks, we can put our fancy E. For, let's say, Japanese or something, we can just use the fancy brackets. An ancient Sumerian language, why not? Somehow it's supported. Yep, backticks are fine. Or this looks like we can actually have a name of the table, also just emojis, because why not? Our library of books. There we go. And in all the results, as you can see, we always get stuff converted to just be in those fun brackets. And one thing I was wondering is, what if we actually change it up a little bit? Let's say we take the ancient Sumerian, okay? What if, I'm going to run the query, right? We created it. What if I'm going to, I don't know, put this in here inside the backticks, right? Run. It works. It's just there. What if instead of that, we're going to get the closing one? Because now I think I will need to escape it, right? Run a query. There we go. It's escaped. Just like that. So we can have those symbols in there, no problem. And we can even probably do this and try to do something fun like that. And there we go. It just works. It just gets horribly escaped. But it's possible. Yep. So that's fun. Cool. All right. And parentheses and accessing fields. All right. Now we're getting into more fun stuff. The first item in an array is at index 0. So you can use 0 to grab it. And this is correct query. We just create a table of those 3 elements and ask for the first one. And there we go. First is this thing. Let's just make sure it actually runs in our database. So this is not really fetching anything from the database. It's just evaluating the query. It's just fancy calculator or just programming language, right? And since statements like create return an array of results, you might want to pull out the result at a certain index too. But if you just add a 0 at the end of create statement, it won't work, because place 0 is telling the database to take the first item of a value that doesn't exist yet, a table named place that it hasn't looked up yet, not the create statement itself. Oh yeah, this is not great, because the database sees, oh, this is create, and we take the table place and grab the first element of that table, and then we create it. No, cannot execute create statement using a value of none, because we can't really do that. So to fix this, surround the whole statement in parentheses first. So there we go. We have create place. That was in parentheses. And then of the result, we take the first element. And there we go. We get it, right? Create place. And run, and we just have an idea of just created place. Records have an object-like structure that holds keys, fields, and values. You can access a single field by using a dot and then the field name. So yeah, we can basically, in our query, create an object ourselves and just get ID of it. And response will be just the ID, nothing else. As above, you can surround a statement and parentheses and then choose a field to return. So yeah, we can create the place, right? And just extract its ID. The output is an array of IDs because the ID tells the database to go through the array and only gather the values of the ID field. So yeah, because this, in theory, could be many things. If we were to do a select here, to select some things, right? We basically get an array. And if we try to get ID of an array, SurrealDB is smart enough to just go, oh, I guess I need to get an ID of each element of the array. So instead, we could probably just go through the first element, right? So just to demonstrate what we learned, we have the ID, right? And we can see it, it's an array. Well, we can just do, hey, just grab me the first element of the array, which will be a record, and then its ID. Bam, we just got the ID. Wonderful. And not JSON, we want SurrealDB. There we go, this should look a bit more appropriately. Great. So if you want to access more than one field, you can give the output a structure by adding the curly brackets after the dot and putting the field names inside there. So accessing multiple fields, create place. So we create a place record. We set the place type to be library and number of books to be 10,000, right? And this is inside our parentheses. So that's one query. And then we do dot and we try to extract place type and number of books. Therefore, response will be, hey, just that. So I'm going to run that so that I have a database for future, right? Perfect. But we could just say, hey, instead of place number and books, we just want the ID and number of books. There we go. We got that. No problem. All right, deleting records. Awesome. None of our place records have any useful information, so let's delete them to get ready to finally create the one library that we need. Two things to know when using delete are: a delete statement followed by a table name will delete all of the records from that table. Okay, all of them. When SurrealDB performs an operation, it returns the results after the operation. So for delete, it will return nothing, just an empty array. Okay, so here's a quick example that shows this behavior. We create some record and then delete all the entries of this table. Again, this is just the name of a table, so we'll create a random record inside that table. And then we're going to delete them all. So we're going to run. We created something, then we delete it, but we don't have anything in return. If you want to return a state before an operation, you can add return before to the end of the query. And this is used often with delete statements because it shows which records have been deleted. All right, so delete place, return before. So we're gonna do maybe not delete place, but delete some record. There we go. We can see that we deleted exactly the same record. I think they want us to delete all the places. So let's do that. We run that and we have all the places we deleted, including our weird shenanigans. Okay. You can use a where clause to delete records that match a certain condition, or delete on a single record ID to delete just one. So delete everyone named Bill. Might be 0, 1, or more records. So delete a table person, as in all the records where name is Bill. So all the Bills will be deleted. Well, this one will delete just the specific record in the table person that has the specific ID. This can match to multiple, because maybe we have multiple people who have, who have name Bill, but this is always just one. You can also delete a range of records. Delete from person 1 up to, but not including person 3. Okay, and this is including person 3. We just have the equal sign there. So this is again interesting because we can kind of operate on those numbers, and I think it also works on something like dates and whatnot. So that's fun. Okay, field order and objects. Now that all the place records that we used for testing are deleted, let's create one library that we will use in the store. This time it will have 2 fields besides an ID, a name, an address, and a number of floors. To do this, we can use set along with the names of these fields and a value for each. So we do create place, and we'll name that place serial library. Okay, so this is our record ID. It needs to be unique. And we set the name to be a string of serial library, address. There we go, place type and floors. And notice no quotes, this is just a number. So I'm going to copy this, and I know that we'll be operating on that. So there we go. We have it in our database. While the fields inside the create statements were in alphabetical order, the output always will be. All right. There we go. The name, address, place. We have address, floors, ID, name, place. There we go. It's all alphabetical. This behavior is because anything can be compared in order and ordered inside SurrealDB. Even objects can be compared because their fields are lined up alphabetically and compared in that order. So this next example returns true because 9 of floors, alphabetically the first field, in the first object is greater than 8 in the second. So yeah, floors is 9. We have larger than, and this another object, which is 8. And yes, 9 is larger than 8, so we return true. But if we change name to a name, it will now be compared before floors, and because a library, which starts with an A, is less than serial library, which starts with an S. So the output is now false, right? Because it goes, oh, a name, we have A, and A is larger than S. No, it's the opposite. So it just returns false. So we can copy it and simply C. There we go. So interesting to know that, ordering those fields can affect how the comparisons will work. All right, next, tips when selecting records. There we go. Since we have a place record in a database with some fields, we can use a select statement to take a look at it. The select is followed by the field to display and ends with from and the target. In this case, the target is place. All place records in the, place. In this case, the target is place, as in the all place records in the database, basically the place table, right? So select name and address from place. So that should be easy. The output is an array of the address and name fields of every place record in the database. Right now we have just one, this library that we added. Instead of selecting all records from the table, you can add a where clause to just select the one that matches a condition, or ones that match condition, or none at all if no records match the condition. So, for example, Sumerian library was deleted, so it will return nothing. Select name and address from place where the name is this. Yeah, so this is a classic select statements, pretty much same syntax as in something like Postgres. The star operator and refining what to select. So instead of typing out each field, you can use star to show all of them. So select everything, like select all the fields from place records. To select all fields minus a few, you can use omit after the star, followed by the unneeded field names. So select all the fields, but omit the ID from place, right? So We're going to do that. We see, oh, we don't have the ID. We could omit the floors, for example. So ID will show up, but floors are not. But we can do ID and floors that we omit, right? There we go. We can do fancy stuff. Using the value and only keywords. Okay, this is where it's gonna start getting a little bit weirder, but kind of necessary in SurrealDB, in my opinion. You can add value right after the select keyword if you only care about the value of a single field and not its name. So select value, name from place. So basically, you can see that I'm gonna show the difference because it's kind of crucial. So let's say we have without the value. Select name from place, right? We just want the name column. So we're gonna run it and we get an array of objects which have name Surreal library. Okay. Well, if I'm gonna do a second query, which will be select value name from place, look at the difference. We don't have an object anymore. We don't have the label of the field. We just get the value of it, right? So we asked, hey, give me just select the value of name, and that's it. Don't give me anything else. But it's still a list because we could have multiple places. If I were to create place and set name, woo, right? I'm just gonna run that. And when I select it, just only the highlighted section will execute. So we run it. We maybe create 2 of them. And now we're gonna run our select statements. This one has 3 objects with the name. Well, this one just returns the names. So yeah, much better. Okay. The only keyword works in other statements too, such as select. It will always work if you give it an exact record ID, because there can only be one. So select ID from only the place Surreal library. Okay. So when we run this, we can see that, hey, we didn't get an array. It's not wrapped in an array anymore. It just returned just the object because we asked to only that object, so we don't have to have it wrapped in an array. However, if you follow it with just table name, the database is no longer sure that only one record will be returned. Okay, so if we're gonna do it instead of specific record, just place, it will say, oh, expect a single result output when using the only keyword. But I find it not really true, because if we're gonna go to our Explorer and look at place, we have those 3, right? The 2, the test woo, and the 1 actual library. If I'm gonna select those 2 and just where's an action to delete them? Press delete. Wait a moment. 2 selected. Oh, delete records. There we go. And we have just the Surreal library. I'm gonna query this. It returns it. So in case the place the table has just on record, it will still work. So but only in that specific case. It kind of takes the records, and then after it collected all the records, only then it checks if only is valid. You can use the limit keyword here to guarantee a maximum number of records returned. It is followed with 1. The database will know that no more than a single record will be returned, and only keyword can be reused. So let me just quickly do create place. Okay, I'm gonna create a bunch of them. So again, if we're on this, it's like, oh, sorry. Well, we can say, hey, limit 1. When we run it, we got this random one because I don't know. Somehow it's ordered the first But we can just slap on where. Name is Surreal Library. We run this and oh, that's right. We need to probably put in here, limit at the end. There we go. We found that one and we're good, and we can do the only thing. Although in this case, probably limit would be still fine because there's only one record like that. Yeah, but whatever. There we go. Okay. In this case, we should ensure that a single record return is the one that we expect it to be. If we had used a random ID like place something instead of place Surreal Library, we could use where to make sure that Surreal Library is the record returned. So we just did that. Here they're just splitting it into multiple lines. Okay. So selecting from more than a single table name. Now this is where fun begins. A select statement isn't just limited to a table's fields. You can create and name new fields as you see fit. They can be made from the values of existing fields or just made up on the spot. So this is very similar to aliases in normal SQL. So if select name field and we create name and append 3 exclamation marks and we call it the excited name, and then we return always true as is cool from place, right? And we got this fun little record with those things. You can see that excited name has the 3 exclamation marks appended, right? That's great. But also the target after from doesn't need to be a table name either. You can select from raw data too. Excuse me. So here we have a select statement where we actually provided data instead of specifying a table, right? We just give it a list. So there you go. It selected name and address from all those. Awesome. And address is none. Because the second object has no value for the field address, it will show up as none. And this is important here. There's a distinction between null and none that maybe we'll get to soon. You can even select from a combination of table name and raw data. Whatever SurrealDB sees after the from clause can be selected and used as output. So here we have the same thing, but we also do the place, which is basically an array of all the places. And we can also combine multiple of those. We can also add place Surreal Library. Okay, and basically this list with this item will be combined with this list and another item. And when we select it, we have something that isn't happy. Oh, because we have a bunch of places that don't have anything set on them. But that's fine. After we went through those places, we have our array. Oh, we have our first record here. Then we've got our array of those 2 records. And then at the end, we have again the place Surreal Library. There we go. Worked. All right. What's next? Casting and analysis. SurrealDB has a lot of data types with names in lowercase, such as bool, number, string, and array. Most types can be quickly changed into another by using a casting function. To cast into another type, put the target type inside the angle brackets to the left. So we can do select, the name, address, and the floors as a string. Okay, so be cast into a string from a place. One of the fields is called string floors. So yeah, this is the result. The field was called string floors. Why not? Because the operation itself becomes the name of a field when an operation is used to set it, right? It won't make up just some random weird new name. It just uses, okay, it didn't give me anything. I'm just going to literally use the thing it gave me so that it stays predictable. If you find this field name ugly or want to rename it for another reason, you can use as to give it a different name, as in give it an alias. So yeah, there we go. This as floors. And we have floors, but not a number, just a string. Casting will only work as long as the input is valid, of course. So something like trying to casting this string into datetime will work. But casting this string into datetime, it will be like, sorry, I can't really understand that. And of course, we can cast something like a string into Boolean. A Boolean can only be true or false as those strings. So hello there is neither true, neither false. It's just an error. Yep. Casting also won't work for complex types because the database can't tell what you want to do. Take this object, for example, that you would like to turn into an array. So if we're going to take this object and try to turn the array, so it's like, how? And there are so many ways. You might want an array holding each key, or arrays holding each key and value, and so on. In this case, take a look at the SurrealDB's object function to choose how to transform from one type into another. For example, you could use the object values function to just return the object's values. So we call the object values, right? We started here and ended here. So inside of it, we just give it the object. And therefore, and we also have this different syntax for it, which is the opposite, the method syntax, where we take our object and do dot values. I personally prefer that because it's kind of more readable, like, oh, I have this thing, and then I extract the values, right? And it will basically return, hey, this is a list of all the values. We can also do something like object from entries to do the opposite, constructing an object from arrays of arrays. So we basically say, hey, object from entries, and we give it this array, this entire array that contains 3 elements. This array that has address and the value, key and value, key and value. And therefore, it will return neatly constructed object for us. So that's cool. The array map function is another great way to turn one type into another. After typing map, choose a parameter name inside the pipes for each item, and then choose what to do with each item before passing it on. This example of the function takes 2 strings and turns each one of them into an object with 3 fields. The output is an array of objects created by each string. So this is very similar to what you would basically expect the map work in something like JavaScript. So we take this list of 2, this array of 2 strings, and we map it, where each, as we are iterating, each string will just take the parameter name, and we construct a new object. This new object will have the field name with the actual name, so something like Surreal library. Is cool, it will be always set to true, and name is long is gonna be set to the length of the name is larger than 10. So for this one will be name is long, and this one will be false, right? So we got basically the array, but actual objects this time instead of just the names. We can see that this one has the long name, while this one does not. Alrighty, affixes. Going pretty fast this time. But we're not even halfway through, and later and later it gets more and more complex. Okay. So affixes. Another way to make a datetime is by using the D prefix. Affixes look similar to casts, but are instructions to treat input as a certain type, rather than to convert into another type. Thanks to this, the queries below won't even run because the parser can already see that the last one won't work. So something like datetime, yeah, that's good. This time will be, oh, sorry, error. This one works, that's the prefix. Well, this one won't even allow the whole query to run. So basically, as we send the query, this block of text to database, right? It goes first by reading, okay, so we need to take this and cast it to that. And that's one action of plan. Another will be to take this string and cast it to date time. So that's another planned action. Then we have this, and it doesn't look at it from the perspective like, oh, I need to take this and convert it into date time. I need to take this already at the step. Okay, this is a value of this as a date. And it's like, okay, that works. Well, this one will be like, I'm trying to, but I can't. And it fails at the stage, so none of this got executed. Therefore, no return statements happened, right? We'll try to do this. See, the previous ones didn't even run. We just get straight up. There was a problem with the database, a parse error. So basically the query is wrong. We can't even do anything with it. Yeah. Oops. Wrong button. Okay. Another example where you would want to avoid a cast is when using the decimal type. A numerical type used for extra precision or extra large numbers. In all programming languages, a float with too many digits after the decimal point will become imprecise. So you have 1000 and a bunch of zeros and 1. That one will work, right? But if we try to squeeze out a little bit more precision, it will be like, can't represent that as a float. And it will be just rounded down to 1000. But if you use a cast on such a number, the database will first create the imprecise float and then cast it to decimal, right? Because it sees it as kind of two statements. First, take this value, and as it tries to create it, it looks as far as here because everything else lower than that cannot be represented as a float, therefore creates 1000. Okay, I've got 1000, I'll change the decimal, it's still 1000. See, it responded as 1000 decimal. Using the DEC, the decimal suffix, solves the problem by telling the database to treat the input as a decimal instead of float. So this is a single operation. It's just, oh, this is a decimal value of that much, and therefore it actually gets proper response because it's properly stored as a decimal from the beginning. All right, updating records. This is really going fast, right? This is awesome. A library all on its own isn't all that interesting. So let's create the town that holds it. So create town Riverdale, set name Riverdale. I'm gonna do that, and bam. Got the town, and in the meantime, I also want to delete a place where whatever was a place type. That's the floors isn't 8. Where floors is none. I want to run that. And now we refresh our places. Okay, we've got just our library here. And in town we have Riverdale. So that's awesome. Great. All right. We created. If we want, we can select both the library and town inside a single statement, right? Select from and place and town. Even though these are two different tables, we can do that, no problem. And we'll just respond with, hey, here's our library, here's our town, and that's it. However, while these two records have turned up in the same query, they aren't actually connected to each other. It would be nice to link one to another so that we could always access the library inside queries on the city. To do this, we can update the town record to add a link to the library. So update is similar to create in that it can be followed by set to set values for the field. And like select statement, an update for a table without a where will update every record for the table. A where clause isn't truly needed here because we only have one town, but let's add it to make it clear. Also, this will guarantee that only the town of Riverdale gets updated ever, even if we add more town records later, right? So to practice, we will first update Riverdale to give it a population of 75,000. So we update the town where the name is Riverdale, and we set the population to 75,000. Okay, so let's run it. And we can see that this is our updated record. Beautiful. Now we know how to update records. We can update this town again in the next page with a link. Okay, so linking records. It's time to update the town of Riverdale again, this time with a link to the library. A record link is quick to make in SurrealDB. If a field contains the record ID of one or more other records, that's a link. For our existing town Riverdale record, a simple update statement is all that is needed. Don't forget to put a library inside an array because the town may have more libraries to add later, right? So we update the specific town. This is again not just a table. We can update specific town. And we set the libraries to be an array that holds currently just one object. Okay? There we go. The libraries are set. If we had used a random ID instead of place or Surreal library, we would have first used select value ID to get the record ID of the existing town and library, followed by a where clause to the filter. Let's practice this method too. So we can select value ID from place, where Riverdale in address. So this is an interesting one, right? So let's skip that. But basically, we take the place table and we filter it out to find an address that contains Riverdale somewhere in that string. Okay, so this is like lookup inside a partial lookup, partial string matching. And then we grab the ID and returns value rather the entire record. So this is going to be fancy because we get just an array of the ID. Again, if we were to remove the value, we would get entire kind of ID place inside of the object. So this is fun. And in this case, we could actually do from only place because there will be only one matching, but just in case, limit 1, and we get literally just the ID, nothing else. All right. When working with random IDs like this, using let to create a parameter is a great way to make the code readable. To set a parameter, which is basically like a variable, use the let keyword followed by the $sign and the name that you want to give it. Okay, setting a parameter also makes it available for reuse, which can be convenient. Okay, so basically, easy to read. This will be IDs of towns with the name Riverdale. So we basically create a whatever, let's go parameter, sure, Riverdale, and its value will be the whatever this returns, which is find a town with the name Riverdale and return just its ID. Okay, so Riverdale will be a IDs of towns with the name Riverdale, right? So currently it will be just one, but that's it. That's an array. Then IDs of libraries with the name Riverdale and the address. So we have all the libraries. So we take the place where Riverdale is in the address and take their IDs. These two are lists. Then update one with the other. So update all those Riverdale entries or the records. And we set on them libraries, and this is the list of libraries. There we go. So if we had multiple towns called Riverdale, and we had multiple libraries with the word Riverdale in that address, they would all get updated with all the libraries and whatnot. And parameter is still around after that. If we had any cats, we would link them to the libraries too, right? Update cat set libraries is libraries. As long as, of course, this is within like 1 cent query. By using either of these two ways, the library is now linked to the town. If we select from the town table, you can now see the library that we linked. So let me run this. Okay. Bam. And we can see that we updated stuff. Riverdale set libraries. The town has the library set. But we didn't set the other thing. But yeah, it doesn't matter. So by using either of these two ways, library is now linked to the town. If we select from the town table, we can now see the library that we linked. So select everything from town. We return our town ID, and our libraries are set to place SurrealDB. That output is a bit boring though, as the libraries only shows the record name for the library. To make the output more interesting, we can add a .name to the libraries to directly access the place's name. Select everything and libraries.name from town. And this is kind of weird because now our libraries is still an array, but has an object with a name that has a list of Surreal library. It's kind of confusing. Not exactly sure why, but it just works that way. But there's a nicer way, or we can use the dot and again curly braces to select some fields from the linked libraries, such as name and floors. So this is nicer. We get libraries and hey, give me the name and floors of each library. So now we have libraries and we got the first one, which is floors 8 and name Surreal library. So that's our library. We extracted that information. And a quick way to display all the fields of our linked record is by adding the fetch keyword to the end. So fetch everything from town, select everything from town, right? But also fetch the libraries. So what it does is that for our libraries, actually inserts entire objects here instead of the default just ID that we're actually storing. So this is a quick way to kind of expand it. And we can also do like fetch and multiple different field names. Yeah, I actually want to try it. So this, right, will fetch that. But can we actually also fetch the ID so that the record will fetch itself? Yes. ID fetched itself and libraries got done too. Can we do like libraries.libraries? Will that work? It does work, but it doesn't work because there's nothing. Libraries.id. Oh, there we go. Library expanded its own ID to be that. So yeah, it's possible to kind of expand this whole path. So that's kind of cool. We could even do id.id.libraries.id.id. And that's gonna be total mess. Or maybe not. Maybe it just stops at some point and it's like too much. You're asking for too much. Yeah, we can't do ID of ID for some reason. I wonder what is causing this to kind of stop. Huh. Maybe the text that is recursive or something. Okay, great. So let's move on to viewing the database as a whole. So viewing the database as a whole, now that we have some data in the database, let's see what it looks like as a whole. The info for DB command will do this. So let's actually run it in hour, because ours will be a little bit different because we have none of those. We just have tables. We have the library, we have place, some record, and town. While they have just place, some record, and town, we just did more experiments. So the output shows 3 schema-less tables. These are automatically created every time you use create statement for a table that doesn't exist yet. If you want to disable this behavior, you can start SurrealDB in strict mode. In strict mode, you need to manually define anything before you can use it. All of the statements inside the info for DB output are followed by a permissions none clause, meaning that they can't be accessed by record users that aren't core database users. Yeah, the record users is more like used for when you want to connect to the database directly from your clients, something like Firebase or something. And you can do kind of authentication and even like, JWT tokens and whatnot through the database itself. But that's a little bit more advanced topic, so maybe let's not touch on it here. But basically, by default, everything's permissions none, so those users just can't access it. But inside this sandbox, we are logged in as a root user, so permissions none doesn't affect us, right? So we can see that place is like define table place, type is just anything, any kind of type. This is type of table, let's just ignore that. And it's schema-less, and the permissions are not. One of the tables is called sum record, which we created back on page 6 for simple demonstration. While we deleted all of its records, the define table statement to create it in the first place wasn't touched, leaving our database with a defined table sum record that we never used again. Since we won't be needing it, let's remove it with a remove statement. Since the statement to create it was define table sum record, it can be removed with remove table sum record. So in our case, we're gonna do remove table library and remove table sum record. So those two we just run, and now we go info for DB. We should have just place and town. Perfect. The output is none, showing that the statement worked and nothing was returned. If you try to run the same remove statement again, you will see the error like, hey, table sum record does not exist anymore. All right. So next, schema full and schema less. So our database now has 2 schema-less tables. Schema-less means that the table is free to accept any sort of data that we give it. If the tables were schema-full, they would have been much more strict. A schema-full table will ignore input for any field except ID, unless they are defined in advance. So let's say define table schema-full town, right? And we mark it as schema-full. The schema-full town only has one defined field. So defined field population on schema-full town is number. So the query succeeds, but the name data is ignored. So if we try to create a new record inside the table, set the name to Riverdale and population to 75,000, it will basically say, hey, I set the ID and the population, but the name got absolutely lost. It's not applied at all because it's not in the schema, because the schema full table. Yeah, while schema-less would just accept it, right? With schema-less, we can just do crazy stuff with types. So create query output is this, and the info for command works also for other items. So now we have things like we can query the place and town, and we can see that no events, no fields, no indexes, no lives, no tables, nothing. And hello methodates. And 3.0 has different behavior here. Now schema will expect all the defined fields and no more. Oh, that's interesting. So it's kind of nice because this cutting of data, yeah, it's kind of weird. I agree. It's similar to how some, like when you, let's say, need to register for a website, and you have to type in a password, right? And it saves. But really, what happens to me many times is that I use a password generator to, let's say, create a 30-character password. I paste it in and hit, create an account. But what happens behind the scenes, the last few characters were just cut off with all my knowledge. And I thought it went through. I thought my data was saved, my password saved, and then I tried to log in, and it's like, oh, your password doesn't work. It's like, oh, they probably cut off some characters. I removed a few characters, and it works. And yeah, that's a fun thing. Not exactly the same, but removing your data without telling you is kind of weird. All right, so at the end, the input shows that place and town are schemaless without any defined fields. That means that we could create a town with a name that is a completely different type, like a number. Mr. Red says, yeah, and sometimes if a field case is different, let's say name versus capital N name, it wouldn't show up and confuse people. Yep, 100%. Yeah, now just throw an error because data isn't valid. You're dealing with a database after all, right? Okay. That means that we could create a town name that's completely different type, like a number, right? So create town, set name. And we could just set this as a name currently because we don't have a schema defined on the... We don't have... Our schema isn't defining the name as a string. Yep, this is fine. We don't want people to create towns with names like this, so we will create a schema on the next page to ensure that this won't happen. So we delete the town where the name is that, so we don't have it anymore. And this is a little thing returned before, a reminder that, hey, this is what the record was. Okay, so viewing the schema. Another advantage of having a schema is that the designer view, instead of Surrealist, can use it to show a graphical overview of the types used in a database. Without a schema, it isn't able to show much of anything. At the moment, all that it knows is that the database has 2 tables, but it has no idea whether name will always be a string or whether libraries will always be an array that holds place records. Yeah, so we should be able to see that we go to designer, we have place and town, exactly the same. And let me just check something. I'll run this in Surrealist. Yeah, and I get the default one or something right now. It worked for me in the morning, now it stopped. All of those are just randomly this query. Wasn't like that in the morning, so just a notification for you, Mr. Dates. But I don't know if it's just me or something. I wonder if I'll just copy it in the different browser and quickly run in the background. Yeah, the same in a different browser. So, I have an idea. I might have something blocked. Or not. Just gonna click here and try something else. No, don't know. Just saying that we've got something going on. All right, let's resume. As Roulette says, not just you, will be fixed soon, I believe. Awesome. Yeah, it literally worked this morning. But I talked for 2 hours just to myself, unfortunately. Forgot that on YouTube you have to click additional, go live after it shows you the preview, and just forgot. Too long not streaming. All right, The whole table doesn't need to be made schemaful though. Instead, define field can be used to define just one field at a time. This lets the table stay flexible for the most part, except for certain fields that we want to behave in a certain way. Here is the define field statement we used for practice on the last page. So define field, population on schemaful town type number, right? Following this format, we can define 5 fields to ensure that the fields for the place and town records can only be of certain type. So for the place, everything is on place. Define field address on place, and the type is string. And the same, we define a name must be a string as well. And in the town, we have, for the town, we specify the name must be a string, population must be an integer, okay? And libraries is this fun thing that will be described a little bit below. And we can just print them out, and we can see that for the place, we have the address and name defined as type string, permissions full and whatnot, all fun. And the same goes here for libraries, where we have some additional shenanigans, basically a type of this field and the type of all of the array's elements. Okay, so the type of the last define field statement above is a bit long, the option array record place. That is because records are always of type record name. So places are record place and towns are record town, okay? And then the libraries field should be able to hold more than one, which makes it an array of record place. Not all towns have libraries, so we don't want to return an error if town doesn't have this field, okay? Not that we have to specify an empty array, we can just completely skip the field and not have it specified, right? By wrapping it in the option. So the libraries field doesn't need to be set in order to create a town, so it's basically optional. Optional array of record of place. That's it. Once these statements are executed, Surrealist will be able to make much more informative graphical schema for us. So let's actually apply this to our little thing here. We're gonna go to query, run it, and when we go to our designer, look at that. We can see that libraries is optional, and all of its elements of the library needs to be a record of a town. And name, a population, the same thing, and also shows that, hey, the contents of the elements of the library's array point to record of place. So that's fun. How's it going, Metro Days, by the way? How are things? It's probably been, wow, over a year since you were on my SurrealDB live stream. The info for table statements no longer empty. Yep. Okay. And we went through that. Once these statements are executed, Surrealist will be able to make a much more informative graphical schema for us, and we can go to the next one, the literal types and assertions. Okay, this is where real fun begins. It's literal types. While option provides the flexibility to either have or not have a value, sometimes you'll need to have a type that has a number of possible values or forms. A literal type can be used in this case, which is made by separating all of its possibilities by a pipe bar, or by a bar. I like to call it pipe. We can use a literal type for the place type field, which will look like this. So place type on place. And we can say, hey, this might be a building or a tower or a store or school or park or library. You can declare a type inside a query too, such as inside a let statement. This is especially useful when using parameters because it lets you make type checks each step of the way. In the example below, the let name followed by a typo, name instead of name, will work just fine, even though the value will be none, because there is no field called name. But if you declare it as a string, the database will catch the mistake and let you know that the type doesn't match. So we can say the first one is let name is townriverdale.name, right? And it will be like, okay, I'm just gonna hold none, and that's it. Well, here the name specified, hey, you are expected to hold a string. It tries to grab it, it tried to assign none to it, and this will be like, oh, wait, sorry, there's something wrong here, and we'll stop, right? And this will kind of prevent you from, preventing you from making some silly mistakes down the road. Method that says 3.0 going well, Korea on the verge of winter. All right, is it gonna be cold winter or hot winter? Because I remember we have very, very hot summers, but what about winters? All right. A literal type can be used in a let statement as well. So we can say let type, and we specify that type is expected to be either building or school or park. And we try to do place serial library dot place type. It's gonna be like, sorry, no, because this will be a library, right? Response found library for param type, but expected either building, school, or park. So let's check if it all actually works to verify the docs. And there we go, exactly that. We can do that. If we would say that, oh, we allow for library, then it's fine. Of course, none is because we haven't returned anything. We could do return type, and we return library. Awesome. A literal type can even include a combination of values and type names. The following literal can either be a string good or an object with a type with an error type and a message field, both of which also have their own possible values. If you're familiar with enums and tagged unions in other languages, you can think of this as the SurrealQL version of them. Yeah, so we create, hey, this is a parameter result, and it can have value of good, or this object that has an error type field that is either a gateway or unauthorized, so we have already nested stuff, and message field that should be a string. And we just apply this and return a result. And there you go. Works. So I'm just going to borrow this, and we can see that, yeah, it returned. Our type unauthorized message can be accessed at this time. But if we would try to give it something like not found, it will complain because this doesn't allow for that, right? There you go. The error type blah, blah, can be accessed at this time for param result, but expected a good. Oh, found this, but it isn't this. There we go. But if we would make the error type is like a string or something, we'll accept anything, right? It'll be fine. We can even do error type blah. Can it be empty string? It can, just like that. Awesome. Mr. Red says, quick errand, we'll be back in 20 minutes to regale you with tales of Korea in the winter. Awesome. All right. Assertions. Inside a defined field statement, you can also add an assertion clause for the value parameter, which is the value of the field. We've already defined the place type field using a literal, but we could have used an assert in this way to do the same thing. So we could, like for the place type on town, We can say, you know what, it's a type of a string, but we assert that the value is whatever the value that we're trying to set is in this array. So it's either a building, tower, store, school, park, or library, or whatnot. However, we can use an assertion on the population field. With the override clause, we can rewrite the definition, this time asserting that town's population can't be negative. So we can do define field override to be able to update it, population on town, and type is again integer, but we added that we assert that the value is larger or equal 0. So we can have a town with nobody in it, but no town with like negative number of people living in it, because it just wouldn't make sense. Bam, we just updated it. We go to our designer and we can see that if we're gonna go to town, fields, have our population, and we should have, when we click on it, we see something, there we go, field assertion, and there we go, it's there. That sort of stuff. With this assertion in place, no towns can be created that have a negative number of people. If we could try to create a town, population of negative, it'll be like, sorry, found this for population, but field must conform to this specific condition. All right, insert and using JSON. Our library is going to need some books. It will also have employees, customers, and the names of the authors of the books. We can use a single table called person here, because a person can be an employee, customer, and book author all at the same time. As SurrealDB is a document database, by default, it works well with large arrays of objects, whether in SurrealQL format or JSON. So if we had the following JSON data for the employees at the library, we could insert it directly into the database without first needing to convert fields like name into name. Right? So yeah, because JSON needs quotes, SurrealQL doesn't. So yeah, we've got this JSON, right? The most straightforward way to insert data like this into a table is by using insert into, followed by the table name. So I can say insert into person and just give it literally this JSON, and it should be fine. It has been automatically converted into SurrealQL, which is different but somewhat similar in appearance to JSON. Right? So a result is again array. So this nearly the same. And then we've got an object, right? But the only difference here is that, hey, these field names don't have quotes around them. Technically, they can have, but they don't have to. And we got the ID created because we just added them to the database, right? And this wouldn't go through in JSON because this is more specialized type. Inside SurrealList. Okay, so we're gonna do that, right? We're gonna insert this, gonna go to the query, and basically when we run it, there it is. But here we can actually select, hey, we want to see the JSON format. And my experience, we just need to kind of click around, and now we can see that this is a JSON result. And something like person suddenly is just a string. It's not a specifically record anymore. I'll put it back to SurrealQL so that it's a little bit nicer. It has been automatically converted, right? Inside SurrealList, 2 buttons. Okay, this is how you can switch it around. And unless there is a reason to use JSON, SurrealQL is generally the better option because it's easier to see the type. Take this query, for example. Return an array where first element is current time, and second one is this query result, which is grab a town and just grab the first element and return just its ID value. So if the display output is SurrealQL, you can always tell that these output is date time and record ID, right? This is prefix D, so we know that this is a date time. This one is this fun format without any quotes or anything. That's a record ID. If the display output is JSON, you can eyeball the output and probably conclude that this is a date time and a record ID, but they might both be just strings instead, because there's nothing stopping you from creating a string like this or that. We just don't have that extra information. Okay, let's go to for loops. We're exploring the kind of programming language of SurrealDB because the more you learn it, it feels less like a query language and more as little programming language. All right, so another way to work with the items inside an array is to use a for loop. Let me just maybe move the light a little bit. Or maybe somewhere here. I don't know. I have like poor lighting here. Ooh. Going to break things. All right. So is to use a for loop. After for, choose a parameter name like item or person to be used every time the loop occurs. So this is just a name we give it. Follow it with in and the data, and then curly brackets to open up a space in which we can write custom logic for each item in the loop. So inside the loop in the next query, the parameter person can be used to set the fields of each person record. Since each step of a for loop is isolated inside its own space, the output of a for loop will always be empty. To see the results of the person records created in this way, we will need to use a select statement after the loop is done. So we basically say for, and we give it a name person, in, and we have the list, the array, all 3 elements, 1 and 2 and 3. So each one of those will be a person. So we do create record in the person table, where we set the age to be person's age. So let's say age 30, and person name, which will be Sarah Bellum in this case. And that's it. That's what's going to happen for every single element, thanks to for. And at the end, we just select everything from person and we have them created. And that's it. They got their ID randomly generated. Awesome. This is the way that we will create these employees for the library. But we also want to link each other to the library at each step of the for loop after creating them. So run a quick delete person at this point if you are following along separately. This time, the link will be something called a graph edge, which we will first need to learn to use starting on the next page. All right, so this is roughly when I got to this morning, but this time I'm going a little bit faster. So let's continue. Let's learn about basic graph relations. This is where the real power of SurrealDB starts showing up, because we already did some stuff that's, purely document-like. We started adding links and kind of fetching them and adding restrictions to the schema, which is more of relational database style. And now we're going to add graph relations, which are another way to define things, a little bit more flexible than records, just record links, and have interesting way of querying things. All right. The record link method we used a few pages ago is the most straightforward way to make a link. Here is how we created a record link back on page 12. Update town Riverdale, and we said that the libraries is just an array of those records. In this case, just a single one place Surreal library. While straightforward to use, record links are simple connections between records that don't contain any information about the link itself. Okay? But sometimes we might also want information about the link, the relation between the two records. If a library adds a new customer, it will be nice to have a field that shows when the person became a customer, such as set customer since and a date. And a field like customer since doesn't belong to a person or a place, but to the relation between the two. That's right. To accomplish this, we can use a second type of link called a graph edge. These edges are created and queried using their own syntax that uses arrows. Mithridates says, and back, Korean winter is a menu of 2 items. Warm +10 Celsius air from the west, as in from China, and atrocious air quality. Tiny improvements since 2019. Oh yeah. Or -10 for the tail end of Siberian wind. Great air quality. Oh, interesting. So depending on where the air is coming from, it's different air quality. Huh, that's interesting. I'm used to winters in Poland that mostly are very bad air quality because everyone still burns, like, has their own little central heating unit that burns coal, and many people still burn trash. So going outside is like, horrible. Unless you're in a nice city that has like city heating and you don't have this problem. But hey, different place, different experience. Okay, +10, -10. I guess that's fine. Yeah, that's good. -10 kind of tough, but it's good for blood circulation. Here, unfortunately, it will be probably around, well, if it's gonna come to maybe 5 Celsius at the lowest, maybe there will be a few nights where it's gonna come close to 0. But that's it, unfortunately. Today is like 20 or 17, something like that. Yeah, I miss colder states. Alrighty. So add a field like customer since. We want that to accomplish. We can do this. Perfect. This arrow syntax is easiest to get used to by thinking about the links and queries we want to make. You can query in one direction using arrows to the right. So I want to know, then it's a path explanation, and possible metadata. So I want to know where people work. So it's from person, works at, to place, right? Person to works at to place. There we go. So the arrow can be thought as 2. And possible metadata. When did the person start, or how much is the salary, right? This is what relates to kind of this idea of the relation works at, because maybe we just have a person that record that mostly represents just a person, and it's a large system where we can have many subsystems, and there's no point of just trying to cram as much into a person record as possible, so that record grows and you need to go crazy trying to filter out data or fetch tons of data. You might as well just have just that person's basic data, but something like the salary for where they work could be in there, right? And where they started. And maybe I want to know which books people like. So we go from person to likes to book. Okay? And metadata could be maybe how much does the person like a book? And yeah, so person likes, let's say likes very much that specific book. Or the other direction using the left arrow, the arrow to the left. So I want to know who works at the place. So the place to being worked at by a person. Yeah, so the left arrow is kind of the, instead of straightforward 2, it's like, I don't know, there's a linguistic name for that. And so metadata same. So also I want to know who likes a certain book. You could go, hey, I have this book, to being liked by a person. There we go. And we can kind of query the other way around. As the paths show, we aren't dealing with direct links this time, but a table in the middle that has a certain name, like works at or likes. The table in the middle is a graph edge, which always contains two fields called in and out. The in field is where the ID goes for the record that does something, and the out field for the record goes that has something done to it. And the table in the middle can contain other fields, just like regular records do. Now that we have the basics down, we'll start making some graph relations in the next page. All right, so creating graph edges. So let's look at it from a more practical perspective. So to create a graph relation, we can use the relate statement. The syntax for the statement is relate record, graph table name, and record. So basically from record to record through some kind of, edge name. Leading to quite readable syntax, since graph tables are usually a verb or similar word, like place employs person, or person likes book, and so on. Here is what some typical relate statements look like. So create a winter road blog, right? So relate, writer, not winter. Relate writer 1 wrote blog 1, okay? So this record was written by, this blog was written by this writer, or this writer wrote this blog post. Relate reader 1 likes magazine 1. And we said that stars out of 10 is 7.5. I'm like, oh, he really likes that magazine, right? Awesome. And we can see as we create those records, the first one will basically specify a new record ID for that relation. And we have in, which is what kind of came into that, which is the writer 1. And out, where it went to, which is blog 1. And the same thing goes here, but we additionally have the stars out of 10. Awesome. I remember an issue was confusing for me. I don't know if the documentation was as good back then. This is nicely shown. I like it. I still don't know, because I know there are two directional links, and that's kind of weird, but that probably will be touched in more in-depth courses. All right, using the syntax, we can now create the employees inside a for loop and link them to the library at the same time. Inside the query below is an array of objects that contain the employee data. Inside each loop, we can create a single person record using the only keyword and assign the output to a parameter called created. This parameter can then be used in the statement relate, as in created, works at, place, serial library, right? So let's take a look. So we have a for loop, and each element of the array will be person. So we have 3 people. We have Sarah, we have Lydia, and we have Sam. Okay? And for each of those, we will run the statement. We create a parameter created, and we'll get this is the query, right? So we create a person. And we set the age to be whatever was given here, and the name to what it was given here. Okay? We created it. And because create returns an array, we don't want this created to be an array. We know there's only one person being created here, so we can do only, and therefore we get just the object that we just created, the full record. Okay? And therefore we can do relate this newly created record works at and the record of our existing serial library, right? And this will repeat it for each one of them. So when we run this, bam, we get nothing returned because we didn't return anything. This was just a for loop. But if we're going to go to our Explorer we can see that we have person and we have a bunch of them, right? Why do we have them twice? Did I run something before? Oops. Works at is only 3 times. 45. Yeah, 25. Why are they twice? Did I might have clicked something twice. Yeah, I might have double clicked. Although I think some of them are linked. Come on. So an explorer. Oh, we just lost everything, didn't we? Ugh, so annoying. But we can quickly recreate it, although we don't have a table. We don't care about schema. Let's do this. Create place Surreal library. And after that says you can see all the queries at the end of the book. Really, let's take a sneak peek. Done the tour. Okay, all queries used for the scores minus the quick ones. We use. Okay, so we have the place set library, place my library. Okay, but we are not using this one. Create only. Thank you for that. This is helpful. Some record, and there we go. Create a surreal library. There we go. We need this one. So we run this one. Beautiful. Then we create our town and update it with our population. Bam. And then we attach the library to it. Bam. We define our things. Place type. Wait, on place. Oh yeah, we want that too. And then population gets the assertion. There we go. And then we had this thing that we added that we didn't remove. Oh yeah, that's right. And now we got to this, but not yet. We just deleted it at the end. And now we got to the one where we created the relations. Awesome. Run. And now just making sure I don't click overview because this unfortunately wipes everything, which is kind of not intuitive. And at our designer, we can see that we have person and works at, and I'm going to go to our person. Wait, not in designer, explorer. We have 3 people and works at is here. And I believe we can look at a person and see the relation is works at that points to our library. And this is our library that works at. Awesome. And it says copy and paste up to your current page and it'll be back on track. Awesome. I'm going to add a note in the intro to let people know ahead of time that you can do that. That's awesome. Okay, so we did that. Now that the relations have been created, we can look at the works at table to see what's inside. Querying this will be no different than any other table, right? So select everything from works at and we get it here. Each works at table has its own random ID. Has a person and the in field. At the in field, the initiator of the relation, and the place at the outfield, the object of the relation, right? So you say works at who, person, where, place. Awesome. You can always query graph edges in this way if you want. For example, this query shows all the details for all the people at the end part of works at, which in this case shows our person records. So we can do select in and all the fields from works at. So that will basically say the same list, but the in actually shows who, right? All the people that work somewhere. However, the arrows used to create relations are also used to quickly move from one path to the next, and it is this syntax that is usually used when querying them. We'll give this syntax a try on the next page. All right, so querying graph relations. Querying a relation is usually done using the same arrow syntax used in the relate statement to create it. Here is a query on a single person record which returns its name as well as the path. Works at place. The graph query checks to see if the person is linked to the works at table, the in field, because the arrow at works at is going into works at. And if there is a place at the other end, the out field, because the arrow works at place, goes out from works at and looks for a place record at the point. So we can do select name and this thing. So basically from person limit 1. Okay, so this will list all the places that this works at. So we have works at and place is through library, right? And name Lydia Window. So we basically grab the first person, right? And we can see that they work at Surreal Library. Since the place point in the query will look for place records, the for destructuring up the curly braces, the structuring operator can be used to access the fields such as name and address. We'll also give it the alias workplace for readability and remove the limit to show all the person records. So basically, from each person, select name, works at place, and we just want to see the name and address of the workplace as a workplace. So we can see that Cerebellum, workplace, and it's a list, right? Because in theory, there could be multiple relations, like multiple places where that person works. There's no limit to relations. And one of them is Surreal Library. I mean, all of them will be having that, but hey, that's how it works. You can also use a graph query directly on a record instead of using select statement. So get Sam's record ID. So Sam is select ID from only person where name is Sam Schwartz, limit 1. So we basically grab record for Sam Schwartz, all right, just the ID, and then just query from the record ID, no select. So basically we go from Sam, works at, place, and we extract address, floors, and name. And therefore we get a list because there could be multiple places where he works at, and bam, just like that, we found place where he works. So really, it's relatively easy as long as we have the IDs and whatnot. And Mr. says there is no limit to the number of places a person could work at, in this economy. Yep. All right. Turning the arrow around makes a graph query in the other direction from the point of the view of the place record. There is no works at person path because it's not the place that works at the person, it's the person that works at the place. Turning the arrows around will accomplish this. The relation is still visually easy to follow because place works at person still shows that person leads into works at and then into place. The only difference is that place is being used as the starting point now. So we're gonna run, Surreal Library and basically grab is, how would you read that? basically the way I read it is, hey, grab all the names of persons that work at Surreal Library. So I'll put the names of the people that work at the library. So when we run this, we literally get just that, people who work at the library, because we grabbed only their names. So that's fun. Because, you don't have this concept of which direction do I query it from. You can query from whatever direction you want, and you can kind of combine them and whatnot. And on top of that, you can, you don't have to worry about joins or matching things and whatnot. It's nice, and after a while, it gets intuitive. Right, graph relations at greater depth. Graph queries can go much longer than a single step. If the path likes person goes from a person record to another person record, then the path likes person will go one more step down. The result will be the people that are liked by someone that is liked by another. Here is a quick example of this from the X-Men franchise, in which the character Wolverine likes Jean Grey, who likes the superhero Cyclops. Oh no. Here Wolverine likes Hero. Path leads to Jean Grey, the person he likes. But the hero Wolverine likes Hero, paths to Cyclops, who he hates. Well, sort of hates. It's complicated. So we can create a hero Wolverine, and hero Jean Grey, and hero Cyclops. We can relate Wolverine likes Jean Grey. Jean Grey likes Cyclops, and this returns Jean Grey, right? Hero Wolverine likes Hero. But this one will return Cyclops. There we go. For our person records, just repeating works at place would make no sense, because libraries don't work at libraries. Yeah, this is a path that just doesn't make sense. But the arrows can be turned around at the midpoint to from this path instead. So person that works at place which is worked at by another person. This path starts with a person down the works at place path to see where the person works. Once it reaches the place, it then follows the works at in the other direction path to see the people that are employed by the library. Finally, it uses .name to access their name field. Queries can be written over multiple lines, so breaking these paths down with comments on each line can be helpful when you need to come back and read your own code later. So person, start at a person, works at place, go to the place where the person works, and then in the other direction works at person, then go to the people that work at that place and get their names. The end result, all the people that work at a library that the first person works at. There we go. So we can get one person and magically return all the people that work at the same place they work at. There we go. Team members. And we get everyone, all the three people, including the person from which we started, of course. Now let's improve the output a bit by having the team members contain every name except the name of the current person. Since the graph path returns an array, that lets us use any of the SurrealDB's array functions on it. One of them is called array complement and returns every item in one array minus the items in the second array. So we basically do array complement and we have a list of names, right? He is almost always on time. And we just remove always and almost. So he is on time, right? There we go. We can use that at the works at place, worked at person path to return every person's name minus the current person. So select. So we start from a person and we do name, We return name of the person, and this function takes to erase. So it will be first is the list of coworkers, including the person, and then we remove the name of the person themselves as team members. And bam. So we have Lydia, and their team members are those. Sarah, and this is her team members, and Sam, and this is their team members. And this would start to be really complex with something like normal SQL. Yeah, it's something like out of my, initially it's how do I even think about it? It's becomes way more complex than dealing with this, where we can kind of do a little bit by a little bit and arrive at something that we want to use. At least I find it more intuitive. All right, so adding and improving data. The library needs some customers too, so we'll add them. We will use a query that is the same as one we did before. Create some person records and relate them to the library. However, this time we will add 3 automatically generated fields of the customer of table to help keep track of customer histories. They all use a clause called value, but in different ways. The first statement is for when the account is created. Its value is time now, the time when the operation is performed. And it is followed by read-only because it should never be changed. So we just straight up define a field, account created on a table customer of, and value time now, read-only. Okay. Okay. So we don't have that table yet, so let's see what happens. There we go. It already exists. So if I go to explore, we already have customer of defined here. So this is interesting. Oh. Did it again. I'm on page 23. '20, 21, and all the way to this field. There we go, and the last one already exists. Beautiful. So hopefully this works. But I wanted info. Wait, 4DB? That was for everything, right? Yeah. We still have the book, the few other fun tables. Oops. So what was remove table? I think I should do this. Bam. And let's get there. There we go. Now it's good. So yeah, customer of is defined as type any, schema less. Okay, we can live with that. Okay. So going back to page 22. There we go. Or sorry, 23. So we define this, right? The second is called last updated. It also takes a value of time now. Anything with a value clause will be calculated when a record is created or updated, but not when it's simply read. Okay? So the difference is that this one is read-only. So that means it's gonna get assigned only once and then not touched. Well, this one, thanks to value, basically every time we create or update a record in a table, it will be automatically set as well. So we just create this one. Beautiful. And the last field is called customer for, which shows how long a person has been a customer. This time, the value will be followed by something called a future, which is a value that is never stored but calculated every time a field is read. A future is made with the syntax future, followed by a new scope using curly brackets and a calculation to perform. In this case, time now minus account created will do the job. So define field customer for on the table customer of, and the value future, and we just specified right now minus account created. And account created is just a different field that we had before. So this is fun because we don't have to have like a separate view or anything. This is just a field that just calculates itself, because why not? With these fields defined, we can start creating sub-customers. Once they are created, we will do a query on one of customer of tables, use a sleep statement to make the database sleep for 1 second, and then query the table again. So this will be one large query, right? So we basically do for data in this array of data. So we basically have somebody's age of the customer and the name, right? So we have a bunch of 15-year-olds and a bunch of 50 to 65, right? So we have a bunch of records here. And for each one of them, we are basically creating a person, setting their name and age only. Okay, and there it is. And then we are relating the person as a customer of Surreal Library. And that's it. We're not setting any values. Then we're going to do, hey, select and out not name. Oh, okay. So we grab those list of customer of. So this is our table of those relations, right? And from that, we grab the names of what it's pointing at. So this will be basically the name of the library, right? So customer of, and it will be name of the library, when the account was created, the customer for how long, and when it was last updated. We're going to sleep for 1 second. So this is fun to have in the database, I guess. And then we select another one, right? The same query, but the customer for should update that. Oh, they lived for an entire second now. That's how long they are the customer. Select it all, and this should just go as one in one go, right? Run the query, and bam, finished. It just took a second because this needed to run. So the first one was, first query is our basically, what do you call it? For loop, took 4 milliseconds. Then we have our first query. Oh, we just grabbed the first record. Okay. So we see that this is customer of Surreal Library. The customer it's a customer for whole 3 milliseconds. And we see when it was created, when last updated, all that stuff. And then we wait for a second. And then again, we can see that the customer lived for, the customer is for 1 second and 37 milliseconds. So there's just some extra time between here and there. And that's it. It worked. It just automatically calculates. If I'm going to run this again, now it shows that it's living for, is a customer for 1 minute, 6 seconds, and 251 milliseconds. So it's just going to always show up. What if I'm going to do select just customer for, okay, from customer off and all the customers. We see that they are all just, 1 millisecond here and there, and that's it. But yeah, I run again and again and again, and those numbers increase. They're calculated every single time we query the database. Fun. All right. You can see that the customer for field will always be greater number every time it's selected, as more time will have passed since the last query. The library also needs some books. To keep things short, our library will have just the 8 most sold books of all time. The data for each one looks like this: the author, the English title, language, when it was published, and title. When inserting, we can cast the published field as a datetime instead of simple string. This will make it possible to use datetime functions and duration functions or operations like plus or minus. Here are the 2 examples of the convenience you get when using datetime and duration types as opposed to simple strings. So time since the traditional founding of Rome, right? So we get the datetime, let's say January 1st minus the year negative 753, so 753 BC. And for example, same time in hours, right? So this would return that, hey, it's been 2,779 years, 44 weeks, and 1 day. While in hours, because we can probably just run this thing in a little bit more fun fashion, right? Instead of duration hours, because this already is a duration, can we do just hours? Run? Yeah, there we go. We just got hours out of that duration. So, yeah, 24 million hours. All right. For each of these books and the next for loop, we will do the following. Since the author field is a person's name, we'll use it to create a person. The output of the create statement will go in a parameter called author. Create the book, capturing the output in the parameter book, and relate the author to the book with person wrote book, and the book to the library with relate place SurrealDB has book. So this is going to be a longer query, but let's see. So we basically have a for loop. Data will be each book data, and an array of bunch of titles, right? And then is our query inside of what we do for each book. So create the author for each book. Return just the object. So we create a person where we set their name, okay? And we return just the record. So we have the author. Create a book, cast published field from string to datetime. So we have the same thing where we create the book and we return just the book, not the list. And we set the author, English title, language. We cast the published. There we go. And set title. There we go. So we've got a reference to the created book as well. And then we can basically say, hey, relate author, wrote the book, and relate place SurrealDB library has the book. And that's it. This will just set everything up for us. So we're gonna copy this. I know I should have just pressed the button. Run the query. Bam, took 4 milliseconds, and we go to Explorer, and we can see here are our books. We have the has relationships, the persons where we have Agatha Christie and Paulo Coelho. Okay. What the hell did he write that's so popular? Of all time, the book, The Alchemist. I think I heard about that book. With the authors and books in the library, we can do more graph queries. Let's try 2 of them here. What books have 3 of the authors written? Wait, what book have 3 of the authors written? Wait, what books have 3 of the authors written? This is very confusing. Sentence. What? Don't know what are 3. So basically wrote book title, path will show this. We can add a where wrote book to make it only return people that wrote books. So let's see. So we grab, this is a select statement. We basically take all records, all persons that person wrote book. So all people that just wrote books. Okay, let's limit just to 3 people. Or this is probably limit to, in this case, people, yeah. Okay, so 3 persons that wrote books. And therefore, we write their name as author and wrote and book title as books. So the list of books that they wrote. I'm going to run it. We can see that J.R.R. Tolkien wrote The Hobbit, Agatha Christie wrote And Then There Were None, and Lewis Carroll wrote Alice's Adventures in Wonderland. Yep, there we go. And just how we can run over books and authors and whatnot just with that. Awesome. What are the names of the places and the books that they have that has our title? Path will show this. So we take the place, of course, print. So in this case, it will be, let's say, Surreal Library. And then as their books, we do, so SurrealDB Library has, and what book it has, and the title of the book. And this will be the books. So we can see that Surreal Library has those books. Okay. That's interesting. I think that data is a little bit different. All right, let's move on to defining events, because for me it makes sense. And yeah, and Mithra is asking, how about this wording? Which books have been written by 3 sample authors in the database? I guess a little bit more, it makes a little bit more sense. I know it's a weird way to kind of write a sentence, because it's more like, show me books written by some random 3 authors, something of that sort. But I know it's weird. Yeah, it's because it has limit 3 to keep output from being super wordy. Yeah, I know. At the same time, it just confuses. Yeah, I think that wording is a little bit better, because the current one is like, I didn't get it. Until I saw the query, I had no idea what this means. But maybe it's just me. All right, defining events. Oh, I love events in SurrealDB. I wonder how well they're defined here, because I know that I want to kind of put more focus on that as I'm kind of thinking about courses and some tutorials, because I think this is very crucial on how things are ordered and whatnot. One of the most convenient parts of SurrealDB is the ability to define an event whenever a record is created, updated, or deleted, or any combination of the 3. In the last chapter, we created some books using this create statement, but we haven't defined any fields yet. So yeah, let book create only book, set author, English title, language, published title, and whatnot, right? 3 of those fields should always be present. So let's officially define them now. So define the field author to be string, language, and title. Things like when it was published, or maybe separate English title or something. Yeah. Also, we have separate title and separate English title. I see. That's what confused me at some point. So yeah, let's define those fields. There we go. So we go into our designer, and now we see that the book has actual defined fields. So that's awesome. And these have no defined types. Interesting. All right. An English title should also be present, but we can use an event to fill it out or check to see if it has been entered. This is because if the book is written in English, the English title field should be the same as title. We don't want the user error to result in title and English title being different. If the book is written in another language, we should check to see if English title has been filled out. If not, throw an error. Okay. So the define event syntax looks like this. Define event name on table name. Okay, so we define the event on table. Then optionally, when some expression, and then write what you want to happen here. It also gives access to the type of event, either create, update, or delete through a parameter called event, along with before and after for the record before and after the change was made. And method that says, one of the interesting changes in 3.0 is that errors from an inner event can now be seen. Oh, that's awesome. So kind of like stack, error stack or something. So define event might fail on something, then if something throw fail. Sample here, output will be like error while processing event might fail, error while processing event might fail. Error while processing event might fail. Yeah. An error occurred, fail. That's awesome that we have them wrapped like that. That's gonna be very helpful in debugging. So very exciting. Because yeah, like if something is wrong as you're developing a query, it's very frustrating. Very frustrating sometimes to kind of figure out where does it fail. Awesome. Yeah, I'm really excited for 3.0. I'm kind of looking forward to tinkering with it. All right. So we define that. We have the before and after available. So to create our event, we will use the following. When event is create, to do this, check when a book is first created, right? Yeah, so basically this would trigger, these would be events only when the book is created. Check if after language is English. So basically what we wrote is, if we specified in a new record that the language is English, and for update events, the English title field, must be set. If after language is not equal to English, and there is no English title field filled in, then throw an error using the throw keyword and custom message. Okay, so let's look at the code because it'll be, I think, a little bit more readable than this. Define event language check on book when event is create. So this is purely for whenever we create a book, okay? So first we check if, because we have if statement, all right? If the language was set to English, okay, then we want to basically say, hey, you know what? Let's update this. Let's update the book with the English title set to the normal title, right? Because it should be the same. Otherwise, if the language isn't English and the English title is not set, we want to throw an exception. Please enter English title for this written in the language. There we go. And we can see that things like title is converted directly into a string, and after language is converted into string. I'm not sure why we're doing that, because it should be already string. Don't know. Maybe it complains without it. All right, so basically if we don't set it properly, we're gonna get an error, and we'll need to fix it before actually pushing data. So this event defined, we can enter a book without English title field, but the field will be filled using the title field. All right, so let me just grab this and query. We just define that event. All right, so if I'm gonna go to Explorer, or more like Designer, look at the book, I should see that we have event, language check, and we just have it here. This is fun. So that says, I think you are right. Oh, with the string? Yeah. Because earlier we just have the definition that, hey, title and language are always string. So that might have been before that. Because that check would happen probably before we even applied a new value, as in the new value was approved, and therefore before the event hits. So we are guaranteed to have them as strings. Okay, so with this event defined, we can enter a book without an English title field, but the field will be filled using the title field. So create a book, and we set the title to be The Shadow Rising. Author is Robert Jordan, and language is English. And we should have filled in with extra data. So we run it, and when we query the book, because this was create, right? During creation, we got this, but notice that we don't have the English title set here. This is because this returns before the event happens. So this kind of return here, and then the event happens, and then we call our select. So with our select, we can see that our English title is already set. Lovely. Note that the first response is the output of the create statement, which doesn't include English title. It's at this point that the event jumps in and adds the field. And if we try to enter this next French book, the query will fail because we forgot to fill out the English title, right? So the language is French, it's not English, therefore the title won't be copied over to the English title. And yeah, it would just fail. The output this time doesn't show the initial create statement before an event because statements in SurrealDB are all run within their own transaction, including their events. Since the create statement led to an event which failed, an entire statement is rolled back and the book is never created. An error occurred. Please enter an English title for can't read that, written in French. All right, 25. Defining indexes. Oh, and with the events, you can do just so much more. Because we initiate an update and you can react to things on update too. So events can trigger more events, which trigger more events, which trigger more events. So you can kind of propagate changes automatically, or I would say automagically, a term some people absolutely hate. So yeah, this is fun. Defining indexes. Indexes can be defined in SurrealDB for a number of ways. See, indexes is the thing that I know they exist, but I don't know what's the most optimal way to use them. So I'm hoping that those courses will kind of make it a little bit more approachable to see which indexes are used when and how to understand it. Yeah. The main reason for an index is faster data retrieval. This is used most often when you need to use the where clause in a query, which results in a full table scan. But with an index, this is much faster. So create a person, set name Billy. Okay, so create a person. Create 25,000 more records, each with a random string for a name. So create, and this is a fun little syntax to create 25,000 person records. And set name random string 10. Return none. A method that says 3.0 has a new index called a count index, which lets count work instantly. Nice when you have lots of records. Ooh, that's nice. So basically keeps track of counts for some, I guess, specific. Oh, I wonder, is it count for specific, like specific where clause, like for some filter, or is it count as keep track of total number of indexes of records in here? Because that's interesting. All right, so we create those 25,000 persons, and then lots of persons records to look through. So select everything from person where name is Billy, right? And it will be a lot. So we can add an index, define index, name index on person's field name. Same query is much faster now. So we don't see that thing here. So let's do that. And each line should be reported how long it took. Run. Okay, so the first one, we created this record. Then it took 496 milliseconds to create all the 25,000 records. And then we have another 133 milliseconds to just find Billy. All right, because he was buried somewhere, probably at the end or who knows where. Because we're looking for all the Billys. So we needed to look through entire database. And then we have query 4, which is create the index, and the index took 427 milliseconds, so longer than querying the whole thing. But now suddenly to find Billy is fast. I can run it and it's 1 millisecond. Yeah, or sometimes below 100 microseconds. So it's rather fast. What if I'm gonna random string? This is 5 letters. And I'll do create a lot of records. I want to see if by any chance it's gonna generate another Billy in there. And this is gonna probably make creation a little bit slower because index needs to keep track of it. And this is 2.5 million. Okay, we're gonna return to that. In the meantime, our database has nowhere near 25,000 records, so an index for faster lookup times won't be necessary at this point. However, an index has other uses, such as being able to ensure that records are unique. To do this, just add the keyword unique to the end. One place we can use a unique index is the address field on the place table. So define index, unique address on table, place fields, address unique. Create place, set, name, address, and place time. So basically we won't be able to create another place with the same address as our library, right? So be an error. Sorry, the database index already contains this with record place Surreal library. There we go. It even tells us what other record it is that has the data. Which I wonder how it relates to security. What if you have rights to create something, but you don't have rights to read? And therefore, this could be leaking important information. I wonder if this error message changes depending if you have rights to read from that table or not. The thread says right now it's just for an entire table. I think it will get refined with other options later. That's awesome. Haha, what's the chance of second Billy? Interesting experiment. Yeah, I bet there will be some Billy and such people. Yeah, not sure if it will be just 2.5 million records. I don't think so. There's no way. Yeah, there is no way. It's just The number of possibilities is so great just with 5 characters. Yeah. In the meantime, let's create another. Just takes a short time. All right. So this is awesome. I'm just gonna copy that and just add note. To do. Check how the unique index error message changes if one has rights to read from a table or not. Error returns the ID of the conflicting record. Okay, and let's paste it in here. And let's also slap on. There we go. Okay. So a unique field can be defined on multiple fields too, such as this one defined on the in and out fields of a graph edge. This is used quite often to make sure that a relate statement can't be used more than once on the same 2 records. Yep. So define index can only like once on table likes where the in and out are unique. There we go. So yeah, just one link from one person to another. And when we try to do it twice, we of course have the same error, which is awesome. So next, improving the schema. The designer view inside Surrealist is able to show the link between town and place tables, but the other regular tables and graph tables are just floating around on top. You can experiment for yourself by pasting all of your queries so far into Surrealist, which should give you the following view. Yep. At the moment, we don't have the random. Oh, maybe we have the person. Who the hell knows? In the meantime, let's check this. Oh no, this is still running. Wow. That query is still running. Weird. I just added another 10.5 million. How difficult is that? Unless the index is freaking out. All right. We've got that. So at the moment, the relations table is, in particular, are vulnerable because they have not been defined as relation tables. Without this definition, a regular works at table could be created and the database would accept it. Like create, works at, set, name is this and that. Yeah. This can be fixed by using define table along with 3 clauses. Type relation to ensure that it can only be used as a graph table. In record name, out record name to set the record type that can be used, and override after define table because currently the existing tables are defined as schemaless non-relation tables. With all override, the database will return error saying that table already exists. Since we have 4 graph relations set up, our define table statement will be enough to improve schema output. So define table works at type relation, in person, out place. There we go. And we do another one, another one, another one. There we go. So let's copy that, and this should transform it into having lots of nice arrows. And I guess we can't because we're waiting for the query to finish. If it's even gonna finish. No. Oh, I just have it like this. Whoa. Larger, please. Yeah, no resources are being used for anything. I guess Surrealist used a tiny bit of memory, no CPU. It just thinks. So what we're gonna do is we're gonna open up a new one. And currently our Explorer shows we have nothing. So we are at page 26. So let's go over here. Oh yeah, we can do everything all the way to page 26. Nearly. 20. This, that. 425. And all the way to our new indexes. There we go. Copy. Run. And that was nice and fast. Okay, so our Explorer shows everything. Let's just remove that table. There we go. And we have it all. And now they show up as those little links that these are relational edge tables. So in Designer, we have all those fun arrows. Person points through wrote to book. Person points through works at to a place, while place points through has to book. And all those fun things. So this is really nice. Okay. Awesome. Visualizing graph paths. So that's something I haven't played with yet. I know some people really like that. Surrealist has another neat visual trick, the ability to view graph paths. Let's see what a visual graph paths look like in the query below that shows what places each person is a customer of. After running the query below, click on the button to the left of Run Query and select the graph view. You'll see the output waiting for records to visualize because Surrealist at this point is showing the output of their first query, the find index statement. But if you click on query 1 and select query 2, the graph query, you will suddenly see a set of 12 person records, each pointing at a single place. So we'll define the index unique address on table place, field address unique, okay, and customer from here. Okay, so let's do our query, right? We define the index and then select ID. So we basically grab every person, right? We'll grab a person and then we go through the person that they're a customer of which place and then just return the ID. So we're going to run the query. This one already exists, great. And we have all this fun. So we go to, not combine, we go to graph. And not this query, we go to the query 2. What do we see here? That all those are pointing at the same place. Okay. All right, this is fun. We have 12 records, 11 edges, person and place. So we have some legend here. All right, this is fun. Stray records. These are the persons that don't have any relationships. Okay, that makes sense. And straight edges. Oh, so if we don't want them to have be curved or whatever. Okay, and we configure labels. Specify one or more properties for each table to use as labels in Node Graph. These properties are used for all queries. Any active connection. Okay, let's not go with that yet, but yeah, this is fun. All right. Fun little animations of the graph relaxing. When using graph visualization, you'll actually see all of the links between person and place, not just the customer of and works at. Instead of the right hand of the embedded window is a place called edges where you can select and deselect which edges to show. When you hover over your mouse arrow over the records, you'll see the record IDs. Yep. Okay, so I can also highlight the edge itself, right? Or no, just as a, let's say this person, right? I can see all the links in and out and yeah, pretty much everything. Awesome. This is fit viewport. Ah, okay. Set graph and pulse layout. All right, I see. Okay. You'll notice that the person record just shows a random ID. So we don't know which person this is. We can change the output by clicking on the tab in the corner called Configure Labels and then add label mapping. Click on person and enter the proper name. And do the same for place. Now we'll see names of person records that your mouse hovers over instead of just IDs. Oh, I see. So this is going to be simple. So configure labels, add mapping for, let's say, for a person we want to view them, property name will be name, right? And then another mapping, which will be for place, which will be name, I guess, again. Oh, okay. And then address, place type. Sure, let's put those two. And for a person, we have name. Ooh, they don't show up as suggestions here. Interesting. I guess we don't have anything defined on person like in a schema, that's why. So we close it and now we can see people's names and everything. Okay, this is fun. And these are probably the book authors, right? They're not really using SurrealDB library. But all right. And this one doesn't show the other thing. Okay, just the name. All right. And Mithridates says, whoops, forgot that the same page explains that. There are also a lot of person records that aren't customers of the library. These can be seen if you click the Stray Records button at the bottom right. Yep, there we go. See all the authors. And now we go to confusing part, the recursive queries setup. Yeah. With the town and library part of the database working well, we'll finish off the tour of SurrealDB by showing another one of its newest features, recursive queries and algorithms. Recursive queries let you move down multiple depths, while algorithms let you tell the database to follow all possible paths with a certain objective. To make this happen, we'll first fill out the drop-down section of Riverdale, which you've seen throughout this tour, and the image at the top. SurrealDB has 3 algorithms that help answer questions like this. What is the shortest path from Event Junction to Vector Park? Or what are all the paths within 2 steps from Event Junction? For example, Event Junction to Index Avenue to Surreal Square, or Event Junction to Index Avenue to Statement Street. What are all the unique paths within 2 steps from Event Junction? For example, Index Avenue, Surreal Square, Statement Street, but not Vector Park, which is much more than 2 steps away. Try looking at the image on top as you think about what the answers might be. To set the stage for this, we'll first need to add all of these streets and places. This could be done using relate statements, but a simple record links work just as well, so we go with record links this time. So we basically create street, bowler hat alley. We set its name, it's connected to, and we just specify an array of other IDs. Yeah. So this is where we can kind of already use the record IDs before they are actually created. I think that's something that relations don't really support. So we create all the streets, we create all the places which are connected to streets and places. Okay, so these are just other streets only? No, places too. Okay. And update town Riverdale set streets and select all the streets and buildings, some places and schools, some stuff here. So we can just copy this. Okay, I'm gonna throw that in, run the query. And of course, this is not a graph query, so not really. All right, so we've got the data. The street called Bowler Hat Alley, by the way, is the little one that provides a shortcut from Rust Road to Index Avenue and has a building with an actual bowler hat on the top. Does it? Rust Road. Oh, I guess this is the street. This little tiny one with this tiny bowler hat. Okay, I see. Easter eggs. Also know that one of the streets is an interesting one. A set of bridges and stairs that cross the river at the bottom of the image. This mysterious location is a bit of a maze. Sometimes it takes you to where you want to go, but the other times you can't find your way out. And other times you end up back at the place where you entered. That's why local call it recursive crossing. To represent its mysterious behavior, the connected to field was set to be a future. That is one of 3 possible record IDs. To make it random, we can use the random enum function, which randomly chooses between the value inside an array. Oh, that must be interesting for the algorithms to go through. Oof. So create street recursive crossing set connected to future and just random thing. Okay, I see. Oh, already exists. Okay, great. All right. This is interesting. I think we're just going to finish this little course tonight. Awesome. Recursive queries. After all the setup we did in the last page, let's do a very basic recursive query, starting at the building called Event Junction. Right here. Located at the top left part of the map. Where can we go from here? Here are some of the ways to follow the connected to paths from here. Place event junction connected to, or place event junction connected to dot connected to, or place event junction to connected to. So let's copy it and run it and see what happens. So the first one, just connected to, shows us what's connected. It's connected to Index Avenue or Rust Row. If we do connected to dot connected to, we can see that the Index Avenue connects us to all those places, while the Rust Row connects us to all those places. So suddenly there's like a lot more. Well, this fun thing with 2 shows us, I guess, them combined, right? So we do place event junction, follow 2 links of connected to, possibly, and just remove duplicates probably and present as one single list. So it just does a lot of magic. While the first query simply shows the 2 places that are connected to event junction, the second and third are slightly different. The second query is 2 arrays showing the possible places you could be if you had picked Index Avenue or Rust Row and gone to the next path. The third query is a single array showing the possible places you could be after 2 steps away from event junction. The 2 in the third query is a part of SurrealDB's recursive syntax. You can replace this with a different number or a range. For example, writing ... 6 tells the database to try up to a depth of 6. There are also 3 keywords, so I want to try something. So I'm assuming that if I'm gonna do 1, it's just gonna end up being the same as connected to. There we go. So 2 will be this. And what if I'll go up to 2? Does it mean that Index Avenue and Rust Row will show up? Because Rust Row shows up because I guess you can reach it from the Index Avenue. Oh yeah, you can reach that one too. So it will be the same thing. Yeah, okay. And 3. And we have way more. 10. It's still thinking. It's gonna be a tough one. That's a lot to go through. There we go. And okay, it doesn't deduplicate. it just goes on and adds and adds. Oh no, I barely even started. Holy macaroni, that is a lot. Yep. I heard my computer going little bit tough. Up here you can see that it's just one CPU core. Okay, so it's just one CPU core. All right. All right, there are also 3 keywords that you can add after this number of range, which tells the database to use a certain algorithm. They are path, to show all the paths walked. I'm not gonna use the number 10 because that will be a little bit crazy. Okay, so plus, wait, that'll be path. Do I just do path? No. Plus path. There we go. We go index avenue to event junction, index avenue to serial square, index avenue to this, or maybe from Rast road to bowler hat alley and whatnot. Yeah. Collect, to collect all unique records walked along the path. Okay. And shortest plus some record ID, to show the shortest path to get to a certain record. Okay. The output is really long, so there are just first 2. It shows that you could go to Bowler Hat Alley, then Index Avenue, then Event Junction. Yeah. And this one. Yeah, things of that sort. We looked at that. The output for collect is a lot shorter. Just a single array showing all the places you could visit within 3 steps. It just removes the duplicates, right? Let's try that. Let's do collect. If I'm gonna do 3, do we get another index avenue somewhere? No, if I'm gonna do 10 again, it should be much shorter. Thinking, and it's done already. And that's it. All the places we can reach. Okay, so collect is fun. Yeah, with shortest, you will want to use a range instead of a set number. Let's see if we can find the shortest path from Idiom Tower to push to Main Street within 6 steps. Place Idiom Tower to shortest to street push to Main Street. Okay, that's how we do the search, via the connected to. All right, I like that. I really like that. And run. There we go. 4 steps. Or not even. We go from Idiom Tower to Bowler Hat Alley to Index Avenue to Record Link Way to push to Main Street. There we go. Awesome. What if I want to go to Surreal or like place? Surreal Library. We can't. Okay. The output shows that it can be done in 4 steps. Just in case, up to freaking 10 steps. No, we can't. All right. And all of these algorithms, you can add plus inclusive if you want to include the original record. Oh, okay. It will just add the first one here. That's awesome. Here we use ... for an open range because we don't know what depth the query will go down to. Instead, the algorithm will return as soon as it finds the shortest path. All right. And more recursive queries. All right. We saw that you can recursively traverse a record ID in this sort of way, right? Inside the left side of select statement, though, the current record ID isn't specified, so we need a symbol to refer to it. This is what the @ symbol is used for. So @ means starting from whichever record ID this happens to be. So we do from place idiom tower, right? So this is our place, only one item. So from it, go to depths of connected to. There we go. And returns an array because it's a select statement. So we expect multiple answers, but we have only one because we have one starting point and a connected to column or something we could rename to, and bam. And to get the exact same output as the first query, add value to remove the key name and only turn a single object instead of an array. There we go. Bam. But often there's no point of running the select from, we just return this and it's more fun. All right, nested recursive queries. There we go. The add symbol is also used when you want to put together a nested query that collects the fields of records as it goes. This syntax is a bit interesting, so we'll put it one step at a time. First is a query that returns the ID and name. As before, you can do this directly from a record ID or via a select statement. Okay. Place idiom tower, return ID and name. Same output using select. Oh. I mean, sure, I can see where it's going because one could say just select ID name from only place this. But yeah, I can see that. Sure, we can just say, hey, this current record, grab ID and name. Okay, makes sense. Makes sense. Then add the connected to field to see the connected records. Oh, my camera is a little bit zoomed in. I can't get that high. Then add the connected to field to see the connected records. So connected to, right? Same thing here. All right, great. To include further levels of depth, we'll need to put a number like 3 after the record ID. However, this query doesn't work because the database doesn't know which path to choose to recurse. If we're gonna do place idiom tower and 3 and just extract those, it's like, what do I follow? To fix it, add .at to the path that you want to go down. We'll give it its own alias. So next will be place idiom tower 3, ID, name, and then next. Oh, look at that. Next will be represented by connected to .at. Interesting, .at the end, huh? Same output using select. So we start from here. We do the same thing. Okay, that's interesting. So the output is a single object that goes down 3 levels, showing the ID, name, and next paths. So go from ID, name, and then as the next, we have all this stuff. Whoa, all the way here. So the next is an array, and the first element is this one, which specifies again ID, name, and its own next steps, which is those 2. And from here it can go here, and from here it can go here. So we have 1, 2, and 3 levels. Okay, and here it just stopped. It's like, okay, I'm not gonna follow further. We just have the ID. All right, makes sense. Be sure not to put .dot instead of a number, as then the query will never end. Or to be precise, it will try to reach the maximum level of depth for recursive queries, which is 256, but that's a lot. But the almost endless number of paths will make this impossible to compute. If you're not sure if a recursive query will go on forever, use select statement instead of working directly from a record, because select allows you to specify a timeout. Ooh, I didn't know that. That's cool. Select, and we have basically the same query, just infinite depth, and from only place idiom tower, timeout 1 second. and the query was not executed because it exceeded the timeout. Okay, this is fun. I can see that going for either situations like this where it's like, oh, we are trying to do something weird, it timed out, maybe we need a different approach. Or maybe for situations where we put like relatively low timeout on some not important thing, maybe something for reporting, or something where maybe currently we have lots of traffic, the database is kind of swamped, the query is going on slower, so we'll just put a timeout on it, so just in case we're not gonna halt things or something. And database is too busy, we need to, I don't know, postpone for later or something. All right, and lastly we have the AI vector search, something I looked at previously, and it's kind of fun. AI vector search is all the rage these days. Since SurrealDB has vector search built in, it's easy to explain basics in a single page. Vector search is done using embeddings, which are extremely long arrays of floats that represent the semantic, meaningful space occupied by a string. You can get these arrays by sending in strings to services like OpenAI and Mistral. This is the main way that these companies make money, by coming up with models that represent a string's semantic space, which people are willing to pay for. For example, the following is the result of A Tale of Two Cities by Charles Dickens, if you send it to Mistral's embedded model. And so on for like 1024 floats. Yeah, a lot. The more the number of floats in the array, the more precise it is. That also means that for a short demonstration, you can actually cut down the length of the array, and precision of the float is still a pretty good result. Let's do that with the 8 books in our library. We'll also use define param to put them inside database wide parameter. And here we have just a number of those. Okay. What we want to do now is to go through each book to find 2 books. One that is most similar to it, and one that is the least similar. To do this, we can use a vector function. There are a lot of vector functions to choose from that give either the similarity or distance, but vector similarity cosine is probably the most used. The vector reference page has a convenient diagram showing visually how each type of vector search finds a distance between 2 embeddings. Yeah. These functions are very straightforward, as they take 2 arrays of numbers that it uses to calculate their similarity, right? This one returns this one returns that. So we can use this to calculate the most and least similar books to the books we have in the books parameter. To do this, we can grab the books parameter and then call the map function to do something with each object of the array. We want to pass on the book's title, then the 2 books that are closest and farthest away. So we basically say, hey, grab all the books that we were provided, a map where O is just a book. So book is the book. There we go. Closest is some code here, and farthest is some code here. Getting the most distance match is the easiest part. We only need to get the book's title, the book field, and its similarity as determined by the vector similarity cosine function. The select will be ordered by similarity, ascending order, which is the default ordering. After which we can use index 0 to grab the first result, which will be the least similar book. So our select book vector search similarity cosine. These are the embeddings of the book versus embeddings as similarity from books, and order by similarity. There we go. So basically, yeah, we basically search, like compare to all the books, search, and the most similar book can use almost the same query, except it will return the ordering around the descending order and grab the book at index 1. That's because the most similar book to any book will be the same book, which will be at index 0. All right. So this is the closest. We just have different order by descending this time. There we go. Okay. And then we have books. Okay, so this is basically the whole query, right? There we go. Closest, furthest. And we can see the output that seems to be working. For example, the fantasy book Alice's Adventures in Wonderland is closest to the Little Prince, but farthest from A Tale of Two Cities. And Harry Potter is closest to The Hobbit, but farthest from Dreams of the Red Chamber. Okay. Alchemist is close to Little Prince, far from Harry Potter. Harry Potter is those, and there were none. Close to Little Prince, farthest from Alchemist, Dream of Red Chamber, Hobbit. Huh. Okay. If you want to try the same query with the full 1024 length embeddings, take a look at this page, which has them all. You'll see mostly the same order, especially in very close books like Harry Potter and The Hobbit. But for less obvious similarities or distances, you'll see different books show up with the longer embeddings. Yep. Those were just the basics, but all the rest of vector search is just a more complex way of doing the same thing, finding the similarities and distances between strings. For much more information on this, including an interesting operator that looks like this, take a look at the vector search reference page. Yep. With that, we are now out of time. We promised a 30-minute tour. It's more like 3-hour tour. Yes, it's 3 hours, right? Wait, where do I find the time that I streamed? It doesn't even show up. Oh, well. All right. And that's probably about how long it's taken to reach this point, give or take a little depending on your learning style. Let's wrap it up. All right. Well done, you've reached the end of the tour. While 31 short pages is only enough to just scratch the surface, you are now familiar with many of the main features that SurrealDB has to offer. Check out the other offerings to learn more. And Mithra says some small things you can do. Select add.id name.keys. Oh, interesting. And since now it's an object, yeah. And if you're ex-Conti who pours through absolutely every word, it's 3 hours. Yeah, because I'm talking and then trying it out, and it's different when you're just reading rather than reading aloud. I'm not a fast talker. All right. Check out other offerings. SurrealDB Fundamentals, where you'll build simple e-commerce database guided through both video and text and get a completion certificate at the end. Fun. And then we have Ian's Surreal Renaissance, where you'll immerse yourself in a fantasy book which you follow the main characters in a medieval future that uses SurrealDB to rebuild the world of our 21st century. Okay, this is fun. I'm looking forward to it, actually. I want to see him a little bit more, because documentation shows you what the tools are. It doesn't necessarily shows you how to use them. Like, what are the good decisions when choosing between record IDs or, like record links or relations, right? What are the benefits when to use which one? Why? Or different cases, all those little things. So I'm hoping that there will be, some idea of it conveyed. We'll see. And don't forget to drop by any other parts of our community. The most active part of the community is Discord, which is a great place to meet others using SurrealDB, share what you're building or get advice, and talk directly with SurrealDB employees, including our founders, about just about anything. And finally, here's the entire dataset of the store, including the queries and the first few chapters for records that eventually got deleted. Hope you enjoyed the course. I did, so this is fun. And that's just all the queries. Awesome. So that was it, and we have 2 more courses. So don't know what day exactly, but soon I want to start on, what should I do? SurrealDB Fundamentals or Surreal Renaissance? What do you think? What would be a good one? And Method says the book and Tor have a PR right now for the 3.0 changes. Should be merged in a few days. Ooh, that's fun. That'll be fun to kind of see the updates to the content and see what happens. Let me know when it's merged. It will be good time to start. Method says fundamentals will still be 2.x for a while, so you could choose based on that. Okay. I'll do that then. And book will take at least like 30 days of streaming. Okay, so I guess the book is a little bit more in depth. All right, because with the fundamentals, we have a bunch of probably short videos, right? Let me just sign in. I guess I signed in, even though this one says sign in. Okay, like 7 minutes. All right, reading data. We have like 10-minute videos. All right. So this will take around. Okay, these have some text. This will probably be some days of going through it. We have. Oh, okay. Not tons of like topics, but we go through. Intro, we have record IDs, inserting, reading, updating, so the basics. A little bit of working with relationships. Making a schema full, okay, making secure. So we have, okay, authentication and all the queries. Making performant, okay, that will be probably the most fun part. Okay, so this is like really the fundamentals, I see. And if we're going to get to here, to the Renaissance, yeah, I also wanted to go through it. Something like the Great Book. So this is just reading, right? And we have some more fun stuff. Okay, these are substantial. So we go the Great Book on instant. Okay, so we have like a bunch of chapters. We have some story, time elapse 20 years, a little bbit more here. Okay, looking forward to, wow, this is a lot of content. Yeah, looking forward to 3.0 version of it. I'll probably go through look through the, what do they call it, Tor as well, to kind of pick up on some differences. That'll be fun. All right. Well, thank you for your help, Mithridates, as always. It's a pleasure having you around. I have some notes regarding what I found in the Tor that I wanted to point out. So do you want me to just send you like a list of issues I found, or do you want me to create like a issues on some kind of, I don't know if this is actually like public repo, the SurrealDB University? I'm not sure if this one has links for edit on GitHub. Doesn't seem like. So I don't know if this is a separate repo that I could just put. Okay, so I'll send you over a few little findings that I had mostly this morning to just in case. Yeah, throw in there. All right. Will do. And so thank you, Mithridates, and thank you everyone else for watching, if you're watching it after the live stream. And thank you. And see you around. I'll probably post on Discord again, on the SurrealDB Discord as well, about the next stream. Hopefully more than a few hours ahead of time. See you around.